Welcome to The Explainer. Today, we're diving into one of the most powerful yet invisible forces on our planet. It's a massive river of heat flowing secretly through the Atlantic Ocean, and it acts as a kind of secret heat pump for the entire globe.
So, let's kick things off with a little puzzle. Take a look at London, England, and Labrador, Canada. They're at pretty much the same latitude, right? So you'd think they'd have similar weather. But how come London gets these mild, damp winters, while Labrador is, locked in a deep freeze? What's going on there?
Well, it turns out the answer isn't up in the air, it's down in the water. The secret is a gigantic current of warm, tropical water that works like a planetary heating system. Let's take a closer look at what this thing is and how it actually works.
Okay, Section 1, the Great Ocean River. This current has a name you've probably heard, the Gulf Stream. And calling it a river isn't just a metaphor. It's one of the most significant and powerful currents on our planet, a true force of nature.
The best way to think of it is like a giant conveyor belt for heat. It scoops up all this warm water in the tropics, where the sun is beating down, and then hauls it thousands of miles north, delivering that warmth to places that would otherwise be way, way colder.
Now this is where it gets absolutely mind-boggling. At its peak, the Gulf Stream moves 150 million cubic meters of water every second. To put that in perspective, that's more than 100 times the flow of every single river on Earth combined. Just try to picture that. It's staggering.
And it really does behave like a river. It can be 100 kilometers wide and over a kilometer deep. Its warm, salty water is so different from the surrounding ocean that it even has its own distinct deep blue color. Sailors and satellites can actually see it.
So how on earth does this giant engine actually run? I mean, what keeps this massive current flowing day after day? Let's get into the physics that power this whole global system.
It all comes down to some surprisingly simple physics, wrapped up in a kind of fancy term, thermohaline circulation. But don't let the name throw you. Thermo just means heat, and haline means salt. That's it. The whole engine is driven by just heat and salt.
First up, temperature. This one's pretty intuitive, right? When you heat water up, it expands, gets less dense, and it floats. When it gets cold, it contracts, becomes denser and heavier, and it sinks. Simple as that.
Now let's add salt to the mix. The more salt you dissolve in water, the denser and heavier that water becomes. You can even try this in your kitchen. An egg will sink right to the bottom in a glass of tap water, but it'll float in really salty water. It's the exact same principle, just playing out on a massive oceanic scale. And here's where it all clicks together. This is the engine in action. The warm, salty water of the Gulf Stream heads north. On its journey, it acts like a giant radiator, releasing all that heat into the atmosphere, which of course cools the water down. At the same time, evaporation makes it even saltier. So by the time it gets way up north, near Greenland, this water is now super cold and super salty. It's become so dense, so heavy, that it just sinks, plunging thousands of feet to the ocean floor. That sinking process acts like a giant plunger, pulling more warm water up from the south to replace it. And that's what keeps the whole conveyor belt moving. Now, this massive circulation isn't just some neat ocean feature. It has huge direct effects on our climate, our ecosystems, and even our own history. People have known something was up with this current for a really long time. We're talking Spanish explorers back in the 1500s who noticed their ships were getting pushed off course. Later, you have Benjamin Franklin, of all people, mapping it in the 1700s to figure out why the mail ships from England were so darn slow. Our understanding has just kept getting better and better, from drifting in submarines to tracking it with satellites today. Its impact on the climate is just wow. The amount of heat it delivers to the shores of Europe is equivalent to the energy produced by 1 million large nuclear power plants. Let that sink in for a second. 1 million. It is, no exaggeration, Europe's central heating system.
But it's not just about warming Europe. Its influence is all over the place. That warm water can intensify hurricanes. The spot where its warm water crashes into the cold Labrador current, boom, some of the richest fishing grounds in the world. It even acts like a superhighway for migrating sea turtles on their incredible journeys.
But here's the thing. This vital climate engine, which has been stable for thousands of years, is starting to show signs of trouble. Scientists are getting pretty concerned that it's beginning to sputter.
Yeah, the scientific research paints a really stark picture. The Gulf Stream is part of this larger system called the Atlantic Meridional Overturning Circulation, or AMOC for short. And the data shows this whole system is now weaker than it's been for at least the last 1,000 years.
So what's causing this?
Well, the main culprit is melting ice. As the planet warms, huge amounts of fresh water are just pouring off the Greenland ice sheet into the North Atlantic. This flood of fresh water dilutes the salty ocean surface, making it lighter, less dense. And if the water isn't heavy enough to sink, well, that plunger effect that pulls the current north just starts to fail. The whole system weakens.
And a weaker current wouldn't just be an abstract scientific curiosity. Oh no. It would have very real and very serious consequences for people and ecosystems all over the world.
This slide gives you a sense of the potential impacts. For Northwest Europe, it could mean a dramatic cooling. We're talking severe winters and big trouble for agriculture. For the U.S. East Coast, a slower Gulf Stream could actually make sea levels rise faster. It could even shift vital rain patterns in the tropics, messing with monsoons that billions of people depend on for food and water. It's a global chain reaction.
Now, let's be clear, we're not talking about a Hollywood disaster movie where everything freezes overnight. A full, sudden shutdown is pretty unlikely, but we don't need a total collapse for the effects to be severe. The gradual weakening that scientists are already seeing is, by itself, a major threat to the stability of our entire global climate.
Okay, that was a lot to take in, I know. So let's just quickly summarize what we've learned about this incredible and pretty vulnerable natural force.
Here are the 5 essential things to remember. 1. The Gulf Stream is a giant river of heat in the ocean. 2. It's driven by a global conveyor belt, all powered by simple differences in water temperature and saltiness. 3. Its most famous job is being Europe's personal heating system. 4. That powerful engine is being weakened by a flood of fresh water from melting ice. And finally, number 5, a continued slowdown poses a serious risk to weather patterns, sea levels, and ecosystems all across the globe.
And that leaves us with one final, pretty provocative thought. We know one of Earth's most critical life support systems is under stress, and we know why. The only question that's left is, what happens if we keep ignoring the warning lights flashing on our planet's dashboard?